Hi, everybody. Everyone got quiet, so I figured it means I'm supposed to start talking. How y'all doing? It's the end of the second day. How you feeling? Usually the end of the second day of a conference is when my brain starts turning to mush. So I do really appreciate all of you all actually coming and not standing outside and drinking more coffee, because God knows that's what I want to do right now. When Andrea invited me to do this talk, she had seen a version of this that I did at the Software Craftsman Conference in November. And at the time, this was the title of that talk. This is actually the same talk. I've given it a different title. Because as often happens when I do conference talks, the first time I did it, I wasn't entirely sure what it was about. It was a lot of really interesting information that I gave to people, but I hadn't quite figured out what I was trying to tell them to do or what they were supposed to take away from it. So since I did that talk that time, I've rejiggered this talk quite a bit, and so the name no longer fit, I felt. And it's interesting, I do a lot of conference talk reviewing. And one of the things, to the point where I've got a text file on my desktop that has like the top 3 comments that I often give people on their conference talk abstract. And the very first one in that text file is, this is a very interesting abstract, but it doesn't tell anything, it doesn't tell the attendee anything about why they might want to go to your talk. It's very clear about what you're going to say, but it doesn't tell them why you would want to go. And apparently I can't take my own advice, because this title tells you exactly what I'm going to talk about and absolutely nothing about why you should be interested. So when I talk about the metaphor of software, the first time I did this talk, as I said, it was at SDNA, and those people have sort of opted in to be interested in metaphor, right? Like they're interested in metaphor because they are software craftsmen people, and they have a metaphor that they want more people to use. And so I didn't really have to think too carefully for them about why they should be interested, because they were already there because they're at the conference. So in order to do this talk again at a more general conference like this one, I really had to think about like, okay, well, why do you care? Why does anybody care? Why do I care? And what it comes down to for me is that knowledge gives me power over my environment. So what I did was I renamed this talk How We Make Software, because this talk is really my theory about how software teams work. We have a pretty poor idea in general of how software is made, especially in teams. And it is my contention that a shift in metaphor gives us a new view that's very valuable. And I'll talk about that a little bit later. For now, what I want to say is that understanding how we make software means we can make more of it. It means the software we make can be better. It means that we can have a better time at our jobs, and we can enjoy what we're doing more. And we can take full advantage of all of the amazing new people that are coming in to our communities. So this is me. I'm based in San Francisco. This is my Twitter handle. I basically only communicate with Twitter. You can send me an email if you really want to, but good luck with that. My DMs are open, so if you'd like to get in touch with me, please do it through Twitter. I'm mostly a Ruby and JavaScript developer, and I have also done a lot of nonprofit work. As I said, I do a lot of conference talk reviewing. I run RubyConf and RailsConf as part of my directorship of Ruby Central. I'm one of the founders of RailsBridge, which has introduced a lot of women and other underrepresented folks to programming. And now we have, by the way, I know this is not a Ruby conference, so we have Mobile Bridge and Go Bridge and Closure Bridge. So we're branching out. So if you are interested in participating in any of those, let me know, and I'll hook you up with people. And in my day job, what I do mostly is software consulting. And I want to be really, really clear about the type of consulting that I do, because there's been a lot of folks, particularly in this room for some reason, today who have talked about software consulting. And a lot of them mean different things when they say those words. So people usually mean one of two things when they say they do software consulting. a lot of consultants work on projects, right? So a company needs a thing built, consultant builds a thing, and usually this type of consultant works independently from the client company. So they may work with other folks that are at their company, but they may have sort of limited interaction with any developers that the customer has. Then there's another type of consultant that works on the business, and these are the sort of Deloittes and Andersons of the world, right? They do business process consulting, agile transformations. And these folks generally do get involved with the customer. They go on site, usually they may talk to some of the developers. They usually don't write code. Neither of these is really what I do. One of the things that I've figured out over the last couple of years as I've done this more is that the thing that I do is not really, like there's not really a category for it. I don't know what to call it. I work with teams, and so I work with software teams made up of developers and designers and product managers and QA and so forth. And I work with them usually when they're in transition from one size to another, they're growing. And I help them figure out how to navigate those transitions. A lot of team dysfunction boils down to either they're holding on to a practice that's better suited to a smaller team, or they've adopted a practice too soon that's better suited to a bigger team. And so navigating these transitions is really the key to growing a team, especially when you want to grow it quickly, as people in San Francisco often do. So it usually means some combination of code changes and process changes. And that sounds a lot like agile transformation, which is somewhat horrifying to me. But the difference is that I don't just go and talk to people, I actually kind of move in. So I go on site to people's offices and I sit there, I pair program with their developers, I participate in their meetings, and I try to nudge them in the right direction. And I've seen a lot of teams doing this type of work. And generally my goal is to make them more effective. I want to turn them into an awesome team. Now, I don't have a system for this, or a book, or a checklist. Each team is different, each team needs different things. I do, however, have a particular way that I think about teams and team interactions that's apparently somewhat non-standard. It helps me figure out what to do to make a particular team move forward. So that's what we're going to talk about today. And before I get to that, I want to talk briefly about what an awesome team is. I think of it as a sort of a semi-capitalized phrase. These are the kind of teams we all want to be on. We may not realize we want to be on them. Many developers have never been on one. They're actually disturbingly rare. Let's talk about what they are and what they feel like. An awesome team communicates well, they're thoughtful, they're collaborative, all of these things that we like, but they also get stuff done. They're productive, and I don't mean productive in the way that managers usually mean productive, like KPIs or lines of code or whatever. What I mean by productive is that they get the stuff done that matters. They're building the right thing. And they know that all the effort they're putting into their code is going towards solving an actual problem. And so that's what I mean by an awesome team. I'm being a bit vague because it's more qualitative than it is quantitative, right? In other words, we do not have metrics that tell us objectively when a team is awesome. Despite that, I think there's ways we can make more of them, and the world needs more of them. This is my personal crusade. After I graduated from college, I worked for almost 10 years in software before I was on a team like that. And working on other teams isn't bad, right? But when I started on the first great team that I was with, I was like, so this is what software is supposed to feel like. This is great. So it felt like we were working together for a goal larger than ourselves, right? We had different roles, developers and QA, PM, and designers, but we all trusted each other, and we knew that we had the same goals, and we were pulling towards them as a unit, and we built some amazing things that solved actual problems. There was a recent study in which Google looked at what characteristics all of their high-functioning teams have in common. And across the entire company, across years of collecting data, there were only two things that they had in common. The first was psychological safety, meaning that the people on the team trusted each other and could be vulnerable around each other. And the second thing was that over time, everyone talked approximately the same amount. I think that's fascinating. And that correlates with my experiences of these types of teams. If you get a team that has those characteristics, they can do just about anything. it was at this point in my career that I realized that I don't really like programming. I like programming. Like I'm quite good at it. I enjoy it. It's great. But it's not what gets me up in the morning. What motivates me about software is its power to solve actual problems. I want to be useful. I want to write useful code that helps actual people. And I'm not motivated as much by the actual construction process. Now, in many ways, it would be easier if I were, because most software projects fail to produce anything of lasting value. Project is canceled, code base is shelved, company goes under, or worse, like project is launched, fails to attract any interest. Like one study found that 68% of all software projects fail in this way. That's a big number, right? 68%, more than 2 out of 3. So if you're motivated by building software that actually does things, it can be a bit of a tough world out there. And the most difficult part about that 68% figure is that we don't really know why. This number has not budged over the last 20 years. And that's projects failed despite our personal best efforts on the projects, despite 20 years of large-scale conversion to Agile, despite developer tools and languages that have been constantly improving. A lot of the bookkeeping of programming has been erased over the years, right? Think of all the brain power we no longer have to spend worrying about source control. It used to be a huge time sink. And now it's just faded away into the background. Commit, push, merge. And there's a lot of things like that. There's a lot of things we used to spend tremendous amount of time on that we no longer do, which frees us up to think about more interesting problems. So somehow, you would think that this would help, but over time, the project failure rate really hasn't moved. Now, in a basic sense, right, software projects fail because developers build the wrong thing. We're the ones with our hands on the keyboard. There's a lot of things we don't have control over, but there's a lot of things we do. And we often have the best information about whether or not what we're building is the right thing. So let me give you an example. One of my first projects out of school, we were building a product on top of a document store. Now this is quite a long time ago. There was no MongoDB at this point. Document stores were quite a new thing, very experimental. And my company had produced one. And an edict came down that said, okay, you're going to use this document store on this project. Corporate strategy, right? Cool. Document stores are great at storing documents. But we, meaning like we, the developers, we knew quite well that what we had, the data we needed to store, wasn't really documents, and that it would be an awkward fit at best, right? Disaster at worst. And so we tried to escalate these problems up to the VP, who told us, like, nope, we need a product that uses the document store, and you are it. And we're like, okay, well, maybe we can change the idea of the product to be more like something that fits a document store. So we hit another wall with that, though, because this was a joint project, and there was another VP involved, and he wanted that thing. He wanted that product. So rather than try and navigate those waters, my boss sent our most experienced guy off into the ether to do the data store integration. It's a month later, it's not working. 2 months later, well, it's going to be working any day now. 3 months later, 4 months later, it was technically working. But it was way too slow. And the bottleneck was the data store itself, right? It's a brand new piece of technology. It wasn't designed for the type of load this product required. And a couple months after that, the product was shelved. And the official reason was recorded as the data store is too slow. So that's interesting, right? That's a technical reason. But the real reason had nothing to do with the technology involved, really. The real reason this project failed was a communication failure. Neither of those VPs wanted the project to fail, but they asked for mutually incompatible things. And we, the developers, were the only people who knew that. And that often happens, right? The people with their hands on the keyboards who are making the thing often have the best information about when a project is about to go horribly wrong. So what if we had been able to navigate those treacherous waters and get them in a room together, right? What if we had a map or a model that helped us understand what to do? And in the end, neither VP got what they wanted. So of course, they were both promoted. And what was so difficult about this project for me that made me think about it off and on for many years afterwards was that I was really happy with the code I wrote on this project. When I started, this was my first job out of college, I walked into my office and there was a copy of Code Complete on my desk, Steve McConnell's book from long ago. Still quite a good book, actually. And the team that I was on valued well-factored code and comprehensive tests, and good documentation. I wrote all of those things. But it wasn't enough. I left the project feeling like a failure, right? Despite the fantastic code I wrote, because it had all been thrown away. And I didn't understand what had happened. I did all the things right. I did all the things right that the books told me to do. And years later, after seeing this pattern many more times, probably than I should have needed to see it, I finally figured it out, which is that clean code is amazing, and I love it, and tested code also amazing, love that. It's not enough to make a project succeed anymore. Maybe it never was. Right? To succeed in this new world of software, we need to build something actually useful. We need to widen our focus away from just the code and start looking at what the actual hard problems of software are. We can think a little bit bigger. We're accustomed to thinking only of the code, but we can do it bigger. Perhaps you've heard this quote before: "There is surely nothing quite so useless as doing with great efficiency what should not be done at all." And we spend an enormous amount of heat and energy arguing about test frameworks and marking styles and tabs versus spaces and Vim or IntelliJ. And what we're doing at that point is we're making things more efficient. We're making our process more efficient. Maybe we're making our code more efficient, who knows? And we achieve great efficiency. But there's another important question for us to think about, and that is this worth doing at all? Which sounds like maybe it's the purview of folks higher up in the hierarchy. But remember, you've got your hands on the keyboard, right? Of anyone in the organization, you have the best information about how it's going. And as a result, we have more control over what happens than we realize. And there are many hard problems that they face, but they all have one thing in common, which is that no matter how technical a problem looks, it is actually about people. So perhaps you've heard this quote also: "There are only two hard things in computer science: cache invalidation and naming things." And this is attributed to Phil Carlton. There's a variation on it that I like also, which is not Phil Carlton, I don't think, which says there's only two hard things in computer science: cache invalidation, naming things, and off by one errors. Get it? Like two hard things. Yeah, okay. I like it. Maybe nobody else does. So I think even if you're not talking about the joke version, if you're talking about the real version, this is a very interesting saying, right? Both of these things sound a bit flippant, but they have some interesting depth to them. Let's have a look. So let's talk about cache invalidation for a moment. Cache invalidation is a fancy term, basically just means knowing when an expensive operation needs to be repeated, right? For example, let's say you have a database call. It does some fancy calculations on one of your tables. Table happens to be large, so the call takes 3 minutes to run when you call it. And on the next request, you have to call it again. It takes another 3 minutes. So if these requests are so close together that nothing actually changes, you might decide to cache the result, meaning you run it the first time, save the result somewhere, and then save the result somewhere. There you go. And then on the next request, you can get it out of Redis in this case, rather than running it again, perhaps saving you some time. So cache invalidation in this case is knowing when it is that you need to rerun the scope, right? When do you need to rerun this database call? Because at some point, someone will insert a new row or delete a row or modify a row that will change the result of that call. And so at that point, if you use the cache result, you've got out-of-date information. So part of cache invalidation is knowing when the result would be different if you reran the calculation. So that's complicated for sure, but it's quite straightforward. There's another element to cache invalidation that makes it complicated, and that is knowing when the application actually needs up-to-date data. So maybe this call calculates some stats for the last 24 hours, but people really only care about looking at the data for the previous calendar day. In which case, it's totally fine to generate the results once at midnight, cache it, use that result for 24 hours, and then rerun the calculation. So even though the value of the calculation changes over the course of the day, the application doesn't need or even want, really, in this case, updated data until the following midnight. On the other hand, if the scope returned you new messages for a chat app, invalidating the cache only once every 24 hours means no one's going to use your chat app, right? Part of cache invalidation is knowing when you need to do it, which is not a technical problem. That's a product problem. That's a people problem. You have to understand how the data will be used by the end user and what the business finds acceptable. So at this point, we leave the logical realm of code. We enter the squishy realm of people. The technical aspects of cache invalidation actually are quite straightforward. It's the people part that makes it hard. So let's talk about naming things. Cache invalidation is generally acknowledged as a difficult problem. So naming things sounds like the joke, right? What's the big deal about naming things? Foo or bar or X or I or data. This is a jQuery example. I see this in a lot of JavaScript. The name data here doesn't really give us any information, right? What kind of data? And more importantly, what is it for? The implications of naming things are quite profound, as it turns out. You want names that are the right level of abstraction to support refactoring. And where I run into trouble often is that I don't know what the right level of abstraction is or how to know when I've got it. So the way I think about it is that when you can give something a name that describes both what it is and what it's for, that means you understand the concept that that variable is representing. By what it is, I don't mean like its type, right? Not like string or array or hash or whatever. I mean what it is one level up from that. The name data, actually, in the previous example, was one level up from that. You could have called it object or JSON. But what it's for is the harder question to answer. That's, again, another level up from the programming world towards the business world. Is this a list of the user's posts? Is it a set of search results? And once you can give something a name that satisfies both these criteria, it means the abstraction you're using is the right one. And understanding what abstractions you need and when to evolve them is the fundamental skill of software development. So when Phil Carlson says that naming things is one of two hard problems in software, it's a bit of tongue-in-cheek because naming things is a problem of understanding. You have to understand both the implementation and the application's goals. And naming things is the layer where those two concerns interface. Neither of these things are hard for technical reasons. They're hard because understanding the application's goals is hard. They're hard because understanding business goals is hard. Understanding people is hard. So I think the saying is perhaps due for an update. I've been saying this a couple of different ways. Let's do an A/B test. We'll see which one gets tweeted more. One of the ways that I've been talking about this is that software is people and only incidentally computers. We have people problems. Computers happen to be able to solve some of them. But it's the people problems that are hard, not necessarily the programming. And the other way that I've been talking about this is that the only hard thing in software is people. I'm not super satisfied with this because it's helpful to be a bit more specific, right? What are the hard problems? Can we enumerate them? Can we categorize the different problems we run into? I've shown you some examples of things that don't look like people problems but actually are. Is it possible to generalize? I suppose I wouldn't be up here if the answer wasn't, I think so. I think, in my consulting work, I've seen a lot of teams struggle with a lot of problems that on the surface look different but fall into four basic bins. The first is hiring. And the main questions here are things like, why is it that if you hire a single judgmental, mean person, the entire team can fall apart? Seems like it shouldn't be that way, right? This is confusing. Why is it that when one person quits, you can spend months recovering, even if it didn't seem like they were really doing that much? Why is it that doubling the size of the team doesn't mean you get twice as much done? Why is it that we don't have any metrics for developer productivity? We all know lines of code is not a legitimate productivity metric for programmers, right? We don't have anything that is. Velocity doesn't work, churn doesn't work. The hard problems of software that really cut right to the heart of why projects fail and why we can't predict them even when they succeed is all these questions are about people, and our current models of software development don't help us answer them. Our current models of software development tell us that we are building a product. It's a holdover from the beginning of software, right? When maybe it was more like a product, a physical thing that went through a series of stages, a physical hardware thing that contained, incidentally, I guess, some software on the side. But there's a lot of ways in which this idea and the words that we use that come from it don't really make sense anymore. So for example, we ship our code as if we're like physically sending something away as it rolls off the assembly line. We use the word maintenance, distinguished from development, as though our code were like a washing machine, right? Once it leaves the factory, nothing new is ever added. Only existing functionality is fixed. And we think of a lot of the words that we use and the ideas we have around software, we're thinking about it as though it were done in a factory, not a modern factory, right? An Industrial Revolution era factory. And that's what I mean when I'm talking about the factory. The factory doesn't tell us very much about the people. The center of the factory is the line, the assembly line. It tells us that there are workers. The workers kind of do the same thing all day. They all do one thing. They're fairly easily replaceable. They may be replaced by robots. And this is the model we currently hold, and this is why the problems we have are problems, right? This gives us no guidance about people. If you look at like hiring, it doesn't really answer any of these questions. Why can one bad hire upset the team? It doesn't really have anything to say about that. Why is turnover so expensive? Well, it shouldn't be, because if all they're doing is stamping a metal plate 80 times a day, then they should be able to find another person to do that. Pretty easy. That doesn't help us. Why don't you get twice the number of output from twice the number of developers? Doesn't help us with that either, because this is where this problem comes from, right? People think you can do this because if you build another assembly line, you can actually get twice as many products rolling off it. And why don't you get, how do you measure developer productivity? I mean, productivity, right, you can tell from the word, right? It's an industrial era factory concept. It didn't exist before factories. And when it first came into being, it meant literally counting the number of things that roll off the line, which really isn't a help for us either. And beyond these, how much is software we build really like a physical product these days, right? Certainly not the web applications that I build with Ruby and JavaScript. If you're shipping 6 times a day, it kind of loses the meaning of shipping, because it never actually leaves. It's never done. I mean, even most desktop software these days is web views. And the ones that aren't auto-update themselves. Video games used to be kind of like products, and they would kind of roll, a team would roll along and do a video game and then disband. But even now, like, video games auto-update themselves. They're never done. So not only does the factory model fail to help us with these problems, it also even, the words and concepts it gives us don't really fit. So it doesn't invalidate the model necessarily, right? We've used it for 60 years. It's built us some really interesting things. Human brains are model-making machines, especially human brains belonging to developers. We build representations in our head for how complex systems work. The quality of our internal model is what we call our understanding of the system, right? So our model is good the more it can both explain and predict behavior of the system in the real world. So some models are explicit, as in we see there's a system, and we try to load it into our heads, right? Like an airflow turbulence model or a complex software system. But other models are implicit, like our factory model for developing software. We don't see it as a system so much as just the way it's done. These are the words we use. This is the way things are. But humans have a pretty interesting tradition of turning implicit into explicit when the conditions change enough that it's time to do so. And that change has come for us. I want to look at another transition that happened in Europe about 200 years ago that's kind of similar. And I want to look at how that happened and see if it helps us understand. So I want to talk a little bit about infectious disease models. So the prevailing model for how infectious diseases spread until the late 1800s was called miasma. They didn't call it a theory, right? It was just how it worked. Miasma means bad air, and the theory said that decomposing organic matter released poisonous particles into the air, particularly the night air, and breathing that bad air is what made people sick. So essentially it equated bad smells and night air with disease, right? Swamps in particular were thought to be unhealthy because of the miasma they produced. Here's an illustration from Europe in the 1830s showing cholera invading as a poisonous vapor. And it sounds very simplistic now, but it endured across different cultures for thousands of years because it actually does a reasonably good job of explaining some of the things we see infectious diseases do. For example, people in close proximity to one another often get the same disease. Okay, right, they're breathing the same air. Seems logical they'd be exposed to the same poisonous particles. Miasma also suggested actions to reduce disease, and those actions often worked. For example, the City of London built sewers and cleaned up garbage from the streets because they thought the bad smells were causing disease. And what they actually accidentally did was remove sources of drinking water contamination. Another example of this is that closing windows at night to keep out the bad air, because the bad air was thought to be produced mostly at night, closing the windows also kept the mosquitoes out. And the interesting thing about this was this model was not fully correct, but it was nevertheless very useful. Louis Pasteur, of course, proposed a more correct model in 1861, germ theory, which says that disease is caused by microorganisms, present in a variety of different media, spread by different vectors, airborne, but also including like ingestion, direct contact, and so forth. And so it was at this point, once we had the germ model, that the miasma model was organized and named in order to contrast the two. And this discovery is often presented in the history books as a revolution of some kind. But the truth of the matter was that when Pasteur published his paper in 1861, very few people were surprised. Because it turns out that in the years leading up to his publication, both scientists and the general public could tell that miasma had difficulty explaining everything they saw. They lacked a coherent alternative, but they could see that the model had problems. So what was it about that time that made that happen? It pretty much all boils down to cholera, which spread to the Western world from India between 1842 and 1862. And it spread out along seaborne trade routes. A bit difficult to explain with miasma. And it was the first time that we had seen that type of disease spread. So while there were a lot of good things that miasma explained and it managed to do a lot of good in the world changed, right? Cholera is what changed it. Cholera presented a new set of problems that miasma struggled to explain, and ultimately led to the development of a more nuanced and complicated model, and that's where we are with software. We have a model we've used for 50 years that served us quite well. Parts of it still do. But in the last 15 years, software has changed, and the way we build it has changed, and even the nature of what we build has changed, and our model needs to change with it. George Box is the father of modern statistics. And what he says is that most that can be expected from any model is that it supply a useful approximation of reality. All models are wrong. Some models are useful. And what he means by this is that germ theory is not totally correct either. There are many things it doesn't explain. For example, there appears to be a strongly genetic component to some diseases, which is not explained by germ theory. But adopting germ theory allowed the scientific community to make more progress than was possible with miasma. And to make progress with software, we need a model that helps us solve the problems that we see revealed by our modern practices. And those are the human ones. We need a different model that shows us the human side of what we're doing. Now, there have been a couple of attempts at this. One of them is the software craftsmanship movement, which I guess is probably why I did this talk there first. I call that model the workshop. So in the factory, our model for building software centers on the assembly line where workers are interchangeable. In the workshop, our model for building software centers on a team of developers of different skill and experience levels building a high-quality bespoke product of some kind. Right? It harkens back to the pre-industrial days when manufacturers like blacksmiths and glass blowers, I guess, were trusted to do their job, not treated as replaceable resources. And the software craftsmanship movement sometimes takes this quite literally, right? There are companies out there that use master and journeyman and apprentice as job titles, which to me feels like maybe slightly too literal. Feels a bit like programming cosplay. The workshop model does answer more of our questions than the factory model does. Let's run through them. Why can one hire upset a team? Well, a workshop is a small, tight-knit team. Makes sense that one bad hire could upset that balance as a reasonable answer. Why is turnover so expensive? Well, in a workshop, sometimes you spend years training someone up with no knowledge to an apprentice, journeyman, and master. If they leave in that time period, you lose all that investment. So that's another reasonable explanation. What the workshop doesn't explain very well is things like this. Why can't you get twice the output from twice the number of developers? Why can't you put in another forge and hire, like whatever. You could try and stretch it. It doesn't quite get there. And it also doesn't answer this one, how do you measure developer productivity? Because the workshop suggests that counting output is what you do, that the important thing of software is that it produces things. So, okay, we're up to like, 2 out of 4, right? Feels like we're halfway there. What I like about the workshop model is it pulls focus away from the product and starts to focus more on the people. But it's still fundamentally a manufacturing metaphor in which a thing is produced. And so what I've been thinking about recently is that maybe that's what's wrong. Maybe comparing software to a physical thing is what we need to change. But so much of our identity is tied up in software as a thing. What can replace that, right? Like there's a number of existential questions that this opens up for people, right? Like what is software if it's not making something? And what do we do if we don't build anything, if we don't build products? What do we do? And who are we if we're not makers, right? The developer community seems to identify very strongly with the maker movement. And if we're not making a thing, then what actually are we doing? I go to a lot of Ruby conferences, and this year I've gone actually to quite a few conferences outside the Ruby community as well. And one of the interesting overlaps I've noticed in the years in the communities that I've been involved in is that there are a lot of developers who are involved in or were previously involved in theater, like plays, live acting, musicals, right? There's other overlaps as well. Like our community has a lot of musicians and a lot of economists. But theater always struck me as kind of the odd one out, right? Economics is mathematical. Music can be. Theater is kind of a different beast, and I started wondering about this. So I did some theater in high school, which for me was quite a long time ago. And I saw some interesting parallels, but when I started thinking about this, I did a bunch of research and reading, and I interviewed a bunch of people who did more theater than I did, who still are professionals and are also developers. And so I suggest to you that one interesting thing that we can do here is we can think about software development as though we're putting together a play. And I've been calling this a stage model. When a theater production starts to come together, usually all they have at that point is a director and a script. So they have decided what play they're going to do and who's going to run it, and that's kind of it. And the script is just a skeleton, it's just dialogue. Right? Hamlet was written over 400 years ago, but there are productions of Hamlet today in which the exact same words are said as the ones that were said 400 years ago. But two productions of the same script with people saying the same words can be dramatically different. And one of the main reasons for that, of course, is the actors, right? It's how they decide to play the characters that makes the difference. The actors put the flesh on the bones of a script. Just like a product person might have kind of the bones of an idea, but it's a team that makes that idea real. You probably know that if you give two different software teams the same project, they'll produce dramatically different solutions, right? Even if you give the same team the same project twice, like a rewrite, for example, they'll come up with dramatically different solutions. And the same goes for a play. Even the same group of actors won't do the same production twice in a row. It'll be dramatically different. So once the director has selected an initial set of actors, they all get together in a room and do read-throughs of a script. And this is where they all start figuring out how their character relates to the others. This is a combination of how they are imagining their character and the director's ideas and how the other actors are imagining their characters. And people often change their minds about how they want to play their character based on input and experience in the read-throughs. So they may try a few different approaches to see which one works best. So should you play Macbeth as an insane man in a sane world or as a sane man in an insane world? Those are very, very different readings of the same words. And there's a lot of space in between the lines of a play. That's what makes a good play. And this stage is where the actors make the initial sort of tentative decisions about what goes there, which is not unlike how a software team adapts to different personalities, right? Maybe you're all full stack developers, but there's one person that really knows SQL well, really loves it, and the rest of you are kind of happy to let them do that. You adjust what you do and what you work on based on who else you're working with. And like Rafi was saying this morning, the capabilities of the team also affect the solution. Maybe given the same web project, both teams would build a Rails app or a Node app, but the team with some really great JavaScript people is likely to gravitate towards a single page app on the client side, and a team without may gravitate towards a more server-oriented solution. So you adjust how you work based on who you're working with. You also adjust what you're building based on who you're working with. And you might also adjust how you work, right? You're working with folks that are 2 hours ahead or 2 hours behind, and you might adjust your work time to start and end later to have more overlap. So after you do the read-throughs, a number of things happens. First, the actors go off and do some work on their own, right? They memorize lines, they maybe watch other people's performances of their character, they may read about it. And then simultaneously, they're rehearsing together. As they rehearse, the play grows more and more fully formed, right? The lighting, the costume, the sound, other folks get involved. It becomes harder, or at least much less convenient, to rethink the original decisions about their characters, because now it started solidifying in the form of costumes that go with this performance and lighting and everything else. So, which is not unlike the fact, right, that the more you work on an application, it gets harder to rethink your choice of like JavaScript framework. Even harder to rethink other basic choices. At best, you can make small corrections, and that's because in both cases, you're up against a deadline usually. So for a theater troupe, it's opening night. This is one of the things that I really like about this model, is that it's creativity, but it's on a deadline. Opening night doesn't move. You're gonna go out there and you're gonna do something when opening night comes. It may be embarrassing the first few times you do it, which is why large theatrical productions often start out in like Chicago, for example, before they move to Broadway in New York, right? Much like you might give a closed alpha to some friendly people who will give you some interesting feedback. A theater troupe is free to be as creative as they want, but there's a deadline. Somehow they always hit it. Why don't we always hit ours? I think there's some interesting things we can think about there. And so I want to say a little bit more about the performance phase of this, because I had fairly limited experience working in behind the scenes at theater productions. And so I thought, basically, that kind of once the performances start, most of the creative work is done, right? Just like a lot of people kind of think, well, there's the development phase and then there's the maintenance phase. And I like the development phase, and the maintenance phase is boring. Performance is not all execution, though, right? A play needs a live audience to be real. The actors play off the energy that each individual audience brings. The same play will be quite different if you do it for a matinee of school children versus like a Friday night. And the actors also see how people react in general to their characters, and they adjust depending on what resonates with the audiences that they see, which is kind of like you launch a feature and the way people use it surprises you, or the way they don't use it. And good teams can take usage information and customer feedback and incorporate those into their creative process, just like a good theater troupe can. So let's go back to the hard problems here for a moment. So why is it that if you have a single bad hire, the whole thing can go wrong? In a group of actors, they depend on trust to get them through the bad takes and into the good ones. This is a well-known psychological fact about creativity, which is that in order to arrive at the best solution, you first need to go through the suboptimal solutions. And in order to do that, you need to be able to trust one another well enough to be wrong. You need to be able to surface the wrong solutions before you get to the other ones. This is why Google's finding of psychological safety, I think, is so interesting. You need to have that in a software team in order to get the gel that you want between team members. Because one thing that we know about the safety of being wrong is that judgment just kills that, right? You need to be able to trust your coworkers to be honest about their mistakes so that you can be honest about yours. So it does explain hiring. Why is it that when one person quits, you can spend months recovering? So in a set of actors, swapping out a character halfway through rehearsals has huge ramifications, right? The company already has negotiated a set of roles, but here comes a new actor with new ideas about how that character should be played, depending on when in the rehearsal process this happens. It could mean that everything needs to be renegotiated all over again, basically. And it's the same on the software team. If you lose an engineer, even if you're able to hire for the position quickly, which, kind of good luck with that, right? You're never going to get that exact same skill set in someone else. Inevitably, they'll have different strengths, different interests, different blind spots, and different weaknesses, right? And so if your developer who did most of the SQL quits, you might have to take that on, hand off some of the server-side work to someone that was previously mostly doing front-end, So any personnel changes cause a sea of mostly invisible renegotiation of roles, just like what happens if you swap out an actor. It can take a while to get back to stability. So why is it that doubling the size of the team doesn't mean you get twice as much done? So if you have a play that requires 5 actors, why is it that if you have 10 actors, you don't get twice as much play? It sounds like an absurd question. That's exactly how absurd it is to ask about a software team, right? If you have 5 people, you can make a play out of 10 people. It's not going to be the same play. It's going to be a different play. Everything gets renegotiated, roles get rewritten, things get promoted or squashed. And the same thing happens in a team, right? If you have a team of 5 people and you add 5 people to it, you're not going to be building the same thing anymore. You're going to have a different set of capabilities, and you're going to have a different feeling for the team, and you're going to build something else. And why aren't there any reliable metrics for productivity? You know, it's funny. The last time I did this talk, someone came up to me and was like, yeah, there was a person on my team who didn't ever really seem to write any code. All he did was he went around and asked all of the other developers questions, and they all found it very annoying. And I thought he was doing reasonable work, but while I was on paternity leave, they fired him. And then when I came back, I found that like our productivity just went way down. And the people were like, his manager was like, what happened? And he said, well, it turns out what was happening was that this person was going around and cross-pollinating between all the developers. Go talk to one developer, go talk to another developer, go talk to another developer. So even though they weren't contributing code, they were contributing they were an incredibly valuable part of the team. And when they left, you didn't just lose their code, you lost that entire web of connections that they made. And it's very difficult to measure how useful an actor is to a production, right? Same thing. There may be an actor with a minor part, only a few lines, but the way that they work with the other actors during rehearsals and the suggestions they make can hugely affect the direction of the play overall. I think the interesting thing about this, though, is that theater isn't asking for metrics. They're not asking to measure the relative contributions of the actors in a play, necessarily. They don't think their job can be performed separate from other people. We seem to think that that is possible. I mean, our profession originated in hardware, which has a lot more constraints and is in the end game a physical thing that gets shipped to the customer. And without those constraints, we can do a lot more interesting things. So, okay, look at that, right? All of our things are explained. Job's done, let's go home. Our end game really isn't a product, as it turns out. Any more than Friday night's performance of Macbeth is a product, right? Our end game is an experience, as much as I hate that term. It's an interactive experience in which our customers tell us what they like and what they don't like, and we feed that back into our next release. What the stage model does is it takes the focus off of the thing in the middle. It removes the product from the center of our model and makes it almost invisible. It moves to the periphery. At the center of the model now is the people who are doing the thing. Software development on a great team is a creative process, it turns out. It may not feel like oil painting or writing music, but it's making something. And it should feel like you're all pulling together. It should feel like you're set on the goal, you're making progress. It's a group creative process, not an individual one. And since you're the ones with your hands on the canvas, you better be sure what you're making is the right thing. Using the stage as our model for software development instead of the factory or the workshop puts people at the center of the process, right? Product becomes invisible. And we've known for a while that people are at the center of software. Software is a team sport. Empathy is a core skill for a programmer. I feel like people have been saying these things for several years without a whole lot of why attached. And now we know why, right? It's because software, when you're doing it right, is a creative activity. So the stage answers our hardest questions about software. We're breaking away from our industrial path. forging our own way forward. So to be clear, I am not suggesting that you immediately adopt the tropes of the theater in your development team. The three models can coexist. Remember, all models are wrong, some models are useful. This is not a way to model your team as much as it is a way to keep a model in your head of what's happening and to explain things that you see happening on your teams. The three models are useful for different things. So the factory tells you how the rest of the company works. There's a bunch of people that are not doing creative jobs higher up in the company, and they're going to want things. They're going to want things like metrics and understanding how they operate and why they operate the way they do is extremely useful, especially if you're going to become a manager, because your job at that point is to be the umbrella that allows them to be creative underneath you. By the way, the actual title of this photograph is Corporate Cliché Shot Number 57. And I just love it. I think it's amazing. I really want to see 1 through 56 now. The workshop tells us about, it's still a useful model, I think. The workshop craftsmanship model tells us a lot about the individual acts of programming, right? It tells us what happens when our hands are on the keyboard. It helps us construct career paths. But it's ultimately limited by the fact that it focuses still too much on the code to really help us with the problems that we have that are higher level. The stage tells us how we work together rather than how we work individually. It tells us how we relate to each other. It tells us how we can keep joy and creativity in our work because it's really supposed to be fun. Remember when programming was fun? It's supposed to be fun. The stage shows us what an awesome team looks like. And if you've ever seen community theater, it also tells us what a terrible team looks like. It tells us about people. It tells us about people that are the hardest part of software. So please go make the leap. Take these ideas, use them on your teams, nudge them towards more awesome. You can do this from the inside. You don't have to be a manager. A team of software developers is a web of interconnected communications. And one node on that web has more power than we realize. We need to build software that matters. We don't need any more car sharing services. We don't need any more ways for teenagers to send each other disappearing messages, right? Like, we need software that works on actual problems, on violence and poverty and disease. And these are hard problems. We're going to need creativity to solve them. And we've got so many folks coming into our community right now. This is an amazing opportunity. And we need to figure out how to work with them and how to build software that actually solves problems. Make yourself some awesome teams. Make programming fun again. Thank you. I think we have a few minutes for questions. Anyone have any questions? Over there.
Hi, thanks for the talk. My question is are there any writings or any formalized things that you can point people to kind of help convey this type of thing, especially to the more factory-minded folks?
There is one book that I read. So people have been asking me to write this as a blog post for several months, and I'm much better at talks than blog posts for some reason. So I may get around to it, hopefully. There's a book, oh gosh, I'm trying to remember the name of it now. I can find it and I can send it to you if you come up afterwards. But there's a book that was written by two college professors, one of which is a theater professor, and the other of which I think comes from a business background, business school. And it's basically them sort of comparing and contrasting the ways that they think about business. And that was the inspiration for a lot of this for me. That and like a bunch of conversations over a bunch of beers at various conferences. Anyone else have questions? If not, we could all go get more coffee. What do you think? All right, thank you.